In this problem, we have a scholarship fund that receives a gift of $200,000. It's decided that the money will be invested into 3 different accounts: stocks, bonds, and CDs. CDs pay 3.1% interest, bonds pay 4.25% interest, and stocks pay 8.2% in dividends. It's also decided that the $200,000 will not be distributed equally. In fact, they invest $25,000 more in bonds than in stocks. If the annual income from the investment is $9,925, the question is, how much was invested in each account? Now, it doesn't say it, but each of these percentages up here are assumed to be the percent growth annually. So the first thing to identify is that there's 3 different variables in this problem. Since the question is, how much was invested in each account, and there's 3 accounts, we need 3 variables. It makes sense to use the letter S to represent the amount of money they invest in stocks. Then we'll let the variable B represent the amount of money they invest in bonds. Finally, I'm going to let C be the amount of money they invest in CDs. Now, it turns out since we have 3 different variables, the only way to get a unique solution is to have 3 equations. In fact, if we only have enough information for 2 equations, we would get infinitely many solutions. But it turns out there's enough information in this problem to write 3 equations. For example, we know that the amount in all 3 accounts must total $200,000 because they're investing it all. So the amount of money that was put into stocks, added to the amount put into bonds, and then add that to how much was put in CDs, has to sum to be $200,000. We also know that at the end of the year, the amount of income generated from the 3 funds totaled $9,925. So let's write out how that money was generated. If you take the amount of money put into stocks, we know that it generates 8.2% in dividends. So I'm going to move the decimal to the left twice, and I will get 0.082, and multiply that by the amount of money that's invested in stocks. That will represent the amount of income that we get just from stocks, which should be less than the $9,925. Now we'll add that to the 4.25% interest that the bonds pay. Turning that into a decimal, moving the decimal point to the left twice, you should get 0.0425, and that's times the amount of money we put into bonds. And finally, we need to add the amount of money generated from the CDs, and it says the CDs pay 3.1% interest. So moving that decimal to the left twice, you should get 0.031 times the amount of money put into CDs, and summing the income from those 3 accounts, we are to get this $9,925. So I will set that equal to that number. Now, if this was the only information given, we wouldn't know how much was put in each account. There'd be infinitely many solutions to this problem. But we were told that the amount invested in bonds is $25,000 more than what was invested in stocks. This can be tricky. We tend to think of the word more as addition, and right next to that word we have the $25,000 in the bonds. This leads some students to think that we should add $25,000 to B because it's supposed to be bigger. But think about what we're doing here. We're writing an equation that tells us how to get from one variable to the other. So for example, for me to tell you how much money was put into bonds, I would need to take the amount put in stocks and add $25,000 to ensure that the amount of money put in bonds is bigger. For students that are still confused with this, I often help them by making a quick chart. What students do agree is that we should have more money in bonds than stocks, since it says we invest $25,000 more in bonds than stocks. So this variable should have values that are always bigger than these ones over here. And it just happens as a coincidence that the big number starts with B and the small number starts with S. So for example, if I was to put $1,000 into stocks, what does this equation say to do? It says that the amount in bonds would be 1,000 plus 25,000, so that would give you 26,000. So even though the 25,000 is being added to the S, this doesn't make the amount in stocks bigger, it makes the amount put into bonds bigger. You can see that the amount put in bonds is $25,000 more than the amount put in stocks. Now, since I'm going to use a matrix to solve this equation, I have 3 equations, so I'm going to have 3 rows. We have 3 variables, but then we have the constants to the right of the equal signs, so we will have 4 columns. To create a matrix, we need only identify the coefficients on each of the variable and the constant. So this is 1s plus 1b plus 1c equals 200,000. So you would put 1, 1, 1, 200,000. If I was doing this by hand, I'd put a line here to separate the coefficients and the variables with the constants on the right. Then my next equation has these as its coefficients, so I'll copy them into my matrix, and the constant was 9,925. Finally, in my last row, my variables are not organized the way the first two equations were. On purpose, I ordered my equations such that S came before B, which came before C. Because these are all terms, we can add or subtract and rearrange them however we want. So I need to subtract S on both sides. So normally you would probably write B subtract S equals 25,000. But in this context, the issue with that is that places the variable B before the variable S. So when I subtract that S over, I would want it to be to the left of B. It'll still be negative. So what I'm going to do is, when I subtract the S over, I would just write it as negative S, and then we have plus B. And then if you really want to show the coefficient on C, since C is not a variable used in this equation, you could write 0C. And since I subtracted the S to the left, the only thing on the right side of the equation is 25,000. So now you can see that the variables have coefficients negative 1, positive 1, 0 because there was no variable for C, and then 25,000. So hopefully you learn how to take a augmented matrix and translate it back into a system of equations. This series of numbers 1, 1, 1, 200,000 really means 1s plus 1b plus 1c equals 200,000, and you could read all of them like that and get back to the system. So now we're going to use our calculator to what's called reduce this matrix. So what I need to do is edit a matrix. The word matrix is right here, happens to be blue on my calculator. It's the second function of this key, so I'll press second, and then I'll press this key just below the math button. So here are the buttons that I pressed, and here's the window that led me to. Now I want to edit the matrix A. It doesn't matter really which matrix you pick. I'm going to choose to right arrow twice to get to edit, and I'll press enter to let it know I'm editing matrix A. And it wants to know the size of the matrix. It always goes rows first, then columns. I have 3 rows. Rows go left and right, so I'm going to press 3, enter. That gives me 3 rows. Now I need 4 columns, so I'm going to press 4 and press enter. And if you mess that up, you can always up arrow and change it. Now it's just a matter of typing in my coefficients. For example, I press 1, enter, and so on and so forth. Once you finish typing everything in, you want to take a second look to make sure that you typed everything in correctly. If you make any mistakes, it's very easy to use the arrow keys and move over to where you made the mistake. You won't even have to delete your old answer. You can just simply type over it with a different answer, and it will start over from scratch. Now that I'm done with my matrix, I want to go back to the home screen, and my goal is to get this command called RREF on my calculator, which stands for row reduce echelon form. If you haven't learned how to reduce a matrix in your course yet, that probably doesn't mean a whole lot. For the purpose of this video, it's just going to be a button that will reduce this matrix into a simpler system, but equivalent system, that will give us the answers to the problem. And then in that command, I want to tell the calculator that I want it to row reduce matrix A, the one that we just typed in. But it takes a few button presses to get these two on the calculator. So back to the calculator. You do not want to press clear to get back to the home screen, because that'll clear out whatever entry you're currently highlighting. Press second mode, which is quit. That'll get me to the home screen. To get this RREF command, we need to go back to the matrix menu, which is second matrix, and then right arrow to the math submenu. And since I don't remember what number the command is, I'm just going to press either down arrow many times or the up arrow until I get to apparently letter B, which is RREF. Once you get there, press enter. That pastes that command on there. Now the calculator needs to know which matrix I want to reduce. So I go back to the matrix menu by pressing second, that matrix key. And then since it was the first one, matrix A, I can just press enter. You can press enter at this point, or if you have OCD like me, you might want to put a right parenthesis there. Either way, you get the same answer. The calculator will change the matrix. We say it's been reduced, and this has a classic reduced form over here where you have ones along what's called the main diagonal and zeros above and below all the ones. You'll see why that's important in a second. Let me copy down this matrix. So all I've done here is literally copy what the output of the calculator was, and I need to remind myself the order in which I typed in these variables. If you go up to my system of equations, the order was SBC. This is very important. In fact, I'm just going to write S, B, and C up here so that when I go back now and turn this augmented matrix back into a system of equations, this will make sense. So if I'm reading this correctly, these are the new coefficients on my S, B, and C, and this first row represents an equivalent equation to this equation up here. So what this says is that 1 times S, which is just S, plus 0B, and this means 0 times C, and that would be equal to the 55,000. Now 0 times B and 0 times C does not need to be written because that's just 0, and adding 0 typically isn't written, so I'm going to get rid of that. So what that first row basically says is that S is equal to 55,000. Now you see why it's important that we get these variables in the right order, or we may have found that it was a different variable that's equal to 55,000. In a similar way, this would mean that 0S plus 1B plus 0C, which is nothing, equals 80,000. And then finally 0S plus 0B, which is nothing, plus 1C, which would be C, equals 65,000. So now you can see why we needed a 1 here to keep one of the variables. This is 1C. And we needed zeros everywhere else so that we wouldn't have the other variables in the equation. So therefore, we were given the actual value of C. So the actual context of these variables were S, B, and C were the amounts of money invested in stocks, bonds, and CDs, which was the very question that we began with. The original question was, how much was invested in each account? And our variables were defined to be the amount invested in each account. So therefore, these dollar amounts would be the answers to the question. $55,000 was put in stocks, $80,000 in bonds, and $65,000 in CDs. If you wanted to quickly check that these three numbers sum to be $200,000, that would be very easy to do. So notice if I sum those three amounts, it comes up to the $200,000 scholarship. We also know that the amount put into bonds was $25,000 more than what was in stocks. Notice here, I've added $25,000 to the amount in stocks and got $80,000. This verifies that the amount of money that was invested in bonds is indeed $25,000 more than what was invested in stocks. And that was one of our three conditions. That was right here, $25,000 more in bonds than stocks. The last condition would take a little more work to verify. It said that we get 3.1% interest in CDs, so I'm going to take 0.031, and multiply by how much money was put into CDs, which apparently was $65,000. So that tells me the amount of interest that I got from that one account is $2,015. It's also true that 4.25%, so 0.0425% interest was paid from the bonds, and apparently we put $80,000 in bonds, so I'm going to multiply that by 80,000. And this number, 3,400, is the amount of money we got just from the interest in 1 year from the bonds. But we had a third account, which was stocks, and it paid 8.2% in dividends. And we found that we must have put $55,000 in stocks. So this calculation shows that we made $4,510 from the investment in stocks. To verify the third condition, the problem stated that at the end of the year, we made a total of $9,925 in the three accounts. So if I look at just the amount of money earned in each account from interest and dividends, that would be these three numbers. Summing them up, you see that total from the three accounts, we make $9,925. So although I skipped the mathematics that goes into reducing the matrix, hopefully this gives you an ability to solve larger systems such as 3x3s in an efficient manner.